yesterday. We're doing an ideal gas law, and I finished with the need to do an example question. I already gave them out, sorry, you're too late for them.
78, Fiona. I will never do this.
Andrew 63.
78, 78.
What number are you?
Yeah.
Student number 94? You're a B. Good one. No, not two on the same day. That's too much. You'll have to wait till next week for that one.
Next Monday.
Monday.
But will it be Monday?
Ooh, yeah, you see, you're starting to understand how I work. Yeah, I like it. Will it be Monday? Could be. Should be.
Yes, it should.
Should be.
But may not.
Yeah, you see, you guys learn quick. You're right, yes. But may not be. But we hope it will be Monday. Yes? Alright. We're going to do an example because last time we didn't do any examples, so let's have a look at an example.
Avogadro's number is different for physics and chemistry.
No. Why would it be?
You can say 6.03.
That's what I wrote down, isn't it?
30.
But I had more. Never mind. I think I had decimal places after it. No? Okay. There we go. Right, let's have a look at this one together. We are going to do this one together. I hope after doing this in class yesterday and doing it in chemistry, you should be able to do these. We'll take turns. So I just need you to do a part 1. You have a tank of radius 30 and height 1, 30 centimeters and height 1 meter, and it's filled with helium. And the tank is at room temperature of 26.85, and the tank is under 3 atmospheres of pressure. Question 1. How many moles of helium are there in the tank?
It's more than.
Hmm?
Is it the question from more
No, it's not. Now, let's see. You'll have to use your PV equals nRT formula. You know the P, you know the V, you know the R, you know the T, so give me the N. What?
Can we use another way? Is there another way possible? No.
Yes, there is, but you would need to know something about helium that I didn't tell you. Are you doing this one, Faisal? Yes.
How much?
For what? How many lines should I do?
Yeah. Maybe.
Many because it's countable.
Yeah, how many?
For the first
No,
question.
For the last
Lesson.
lesson I answered.
Ah. Well, I don't know. Ask somebody who took notes.
Can't really help you there.
Maybe one full A4 page.
I think I
That's too much.
I just used
But Fuan makes more notes than you.
1 page.
But you
I'd
can't
say
make
1
more.
page.
But like,
Just
if
leave
you
it.
have
Yeah, this is
a
enough,
little
this is
bit
enough.
in here.
That's okay. That's enough. Yeah. Right, did you get an answer for the first part here yet?
Is there any new formula in this?
Just PV equals nRT. You know this one from chemistry. This isn't new.
Oh, yeah.
Yeah,
So N equals PV over R.
that's what I want.
What's R?
8.31. The same as in chemistry, no less.
So 8.13.
Close to the 8.13.
I don't know, I'm hungry and tired. Is it 8.13 or 8.31?
13.
Are you sure? I can Google it. Anyways, use whatever you think it is. We'll see if you're right.
3-1.
8.31. I think that's what I just said, isn't it? Right. The formula for N is what? PV over PV over RT. Okay. What's the P here?
3 times 101.35 thousand.
10 to the 3.
Yeah.
What's the V?
0.3 squared times pi times 1.
Pi or squared times the height.
Yeah.
Over or. And what's the temperature here?
270 plus 26.3.
Which is 300.
Yeah. No. Yeah. Yeah, 300.
300. So the N for part 1 is 34.48.
That's a lot of moves.
I want a t-shirt that says that. Right. What did I just say? 34.48. By using the formula N equals PV over RT. Right, the next one. How many molecules of helium are there? Does helium occur in pairs?
No.
No, it doesn't.
No.
Well, we can flick back and check because I gave you this here. Helium does not occur in pairs. So the answer is the same. Yes?
Don't we multiply by 6.0
Did I ask for moles or how many?
molecules?
How many molecules? Yeah. So that's big N, which is N multiplied by Avogadro's number. So, yeah, what's Avogadro's? 6.02 10 to the 23, is it?
Yeah.
2.08 10 to 25. How many atoms of helium are there in the tank?
Same number.
The same, because it does not occur in pairs. B. Now, I'll let you do this one. Some gas is allowed to escape from the tank and the new pressure is 2 atmospheres. Now, how many moles are there?
No.
Yeah, do the same thing. Yeah.
They're all the same answer.
What do you mean? What do you mean?
They're all the same answer.
B, 1, 2, 3?
A, 1, 2, 3.
No, A, 2 and 3 are the same. A1 is not the same as 2 and 3.
Okay, yeah.
So I'll give you now a chance. I want you to do B part 1, 2, 3. That sounds about right. Right. Seems a tiny bit. Sounds about right, yeah. You finish all three parts? Faisal? Okay. Which part are you on? Okay.
T is the temperature.
Kelvin, of course.
About 28. From Kelvin to Celsius to 73 minus.
No, that's.
Uh,
And have you got part 3 done as well? Faisal? Part 3?
how many moles SK? Or how many atoms?
For which part?
B2.
Oh, moles, because I didn't mention a word, it meant I was continuing the English from the previous one. What pressure did you use? Good question.
I was doing my
Incorrect. Let's do B now. What did you use?
B was more like.
More incorrect. B, part 1.
Do you take the average of them?
Even more incorrect. B, part 1.
You just use the 1 atmospheric pressure.
Why?
Because that's the constant.
Right, B part 1 is, what is, you open the tank and you let some out, and I said the new pressure is 2 atmospheres, so the N is different. Well, I still have the formula on my calculator, so if I just go back to here, but change my pressure from 3 atmospheres to 2, I get my answer. So 20, the what?
No,
The calculator, what I typed. Yeah. Which part? So therefore, how much escaped? Well, at the beginning, how much did you have?
34.48 minus.
And then some escaped, and you were left with 22.99. So obviously the amount that escaped is the difference between the two. Which is how much? 11.48 is the answer. I'll write delta N. And part 3 is what's the volume. So you have PV equals nRT, the volume of the escaped gas. So V equals nRT over P. The N we know, the R we know. What's the T? The room temperature, isn't it? Yeah, 300. And the P is 1 atmosphere when it escapes into the room. So if I use my calculator again, and 11.48 times 8.31 times 300 over 101.3, 5, like this. 0.28 of a metre cubed. What did you get when you did it using 2 atmospheres? Your answer should be off.
One whole.
Yeah, it should be half it. And when you use 3, okay. Continue. Yeah, so the last part here we'll do is if the tank was left open until no more helium escaped, then how many moles of helium are left in the tank? No, because if there was 0, the tank would be a vacuum and then things would start sucking in.
Atmospheric pressure.
Yes, correct. You have to work out the number of moles in the tank when it's at 1 atmosphere pressure.
Yeah, but isn't helium lighter than air? So
It eventually, it'll escape and exchange places
Yeah,
with the air.
obviously.
Yes. But that if the tank was left open until no more helium escaped, but obviously that doesn't happen because the helium will keep escaping. But it's not really escaping; it's just exchanging places with the air. If you want me to use a different verb, I can. I could say, if the tank is left open until the helium isn't firing out of the valve, how much helium is left in the tank? You know what I mean? Like if you turn the valve, the helium starts spraying out, and when it stops, there's still helium in the tank. It won't stay there forever because, as you said, it's lighter. It very slowly will leave the tank, but very, very slowly, especially if it's a good tank. And if you make the tank well enough, I suppose the helium could be in there for years. We're just used to helium leaving balloons after a few days, but rubber on a balloon is different, Yes, a tank is not a balloon, correct. So, how much helium? You've got it, Yahya, is you have to put the pressure as 1 atmosphere, the volume is still the same, the R is still the same, and the T is still the same. So, calculate the N, please.
that's for you.
Awesome. This is going to be my lunch today because this is the only time I'll get to eat something before 7 o'clock. Not bad. Get an answer for the last part?
Do you want anything more?
No, this will do me just fine. No, I don't need to eat your hat, thank you.
Apple, mandarin, banana.
Far too healthy. Far too
You can
healthy.
dip it in cheese.
Oh, now we're talking. No, it's okay. What the heck is that?
Best cheese ever.
Cheese sauce?
No.
You fried it?
Yeah.
Yeah.
Spread cheese. Dip your finger and it's cheese.
Too fast.
Too fast, but chips is fine.
Fat? Yeah. And he said chip. Yeah, fattening. Yeah, and chips are not.
You have like this.
No.
The chips aren't going to help do that though. Right. What's the last part here?
Is it the same as
You have n equals PV over RT. So what did you get here?
what's the V? The V
The
is
same. Yeah.
11.5.
What did you guys use it? Please type it in, please. Look how tired and hungry your teacher is. Have mercy on him.
Wait, the P is the 1 atmosphere.
Yeah, why are you asking me this? You told me it was.
I said, I'm just checking.
Oh, but you told me it was, and I said it was, so why are you asking me again?
I'm asking you for the values to give you the answer.
But-
like to check if my answer is right.
But why are you asking me about the P?
Because
You're the one who told me what the P was.
Yeah, but you
What?
told us to check. You told us to check, so I'm just... Never mind.
Okay, thanks. Just give me the answer when you have it. That's your final answer. You have okay. Let's see if someone else gets the same thing.
What did you get?
11.5.
Yes.
5 votes.
Hmm?
5 votes.
It doesn't matter. Did you get
Yeah, same.
good enough? Yeah. Okay, so we're going to continue working on more questions now. But these ones I think will be a bit easier because they're shorter. They're all just like one thing. The first one, a student drank 1 cup of coffee. How many moles of cups of coffee did they have?
Enough to get them drunk.
Only if it's Irish coffee. Calculate. This first question should take you 30 seconds to do if you know what you're doing.
Who are they?
Yes.
Exactly. Who
Who
are
said
they?
a student drank a coffee and then beat.
I'm using they as a gender neutral pronoun instead of his or her.
Ireland.
Yeah, there you go.
This is unclear.
1 over.
Yeah.
Correct. 1 over Avogadro's number. Very good. Which is a tiny number. So the answer is for part 1, 1 over 6.02 times 10 to the power of 23. So this is how many moles of coffee you had. So obviously it's a small number because 1 mole of coffee is a big number and you don't have that much coffee. So this is the answer for part 1. Please write it down. You have it? Part 2.
I'm not getting this question.
Air is 70% nitrogen and 30% oxygen.
Yes.
So if you have 1 molecule of air,
Yeah.
you have neither nitrogen nor oxygen because air is a mixture of the two. So a molecule of air is going to be a molecule of nitrogen or a molecule of oxygen. I want you to imagine air is a single molecule. It's not though, because air is nitrogen and oxygen.
Yeah.
But if we imagine it as a single molecule, what would its molar mass be? So it's going to be some kind of averaging of the 2 other gases.
Nitrogen. What?
I gave it to you on the table.
No, you didn't.
I'm going to go back and make you look bad.
Right here.
There's nitrogen, 28, oxygen, 32.
Divided by 2 now.
Now this is what I'm not going to tell you because I want you to see. So you're thinking add the 2 and divide by 2. But that's not quite right because there's more nitrogen than oxygen. So the average should be closer to nitrogen than it is to oxygen. So you might have to use an idea that you used in chemistry in a different topic to deal with isotopes.
Empirical formula.
Atomic thing.
And the circle of learning is complete. So yes, this is how we should be thinking about it. Alright, have we got an answer here?
30, 29.2.
Sounds about right. So, we use this formula that you had from chemistry. We'll start off with the nitrogen. What did I say the molar mass of nitrogen was? 28 roughly. And then for oxygen? 32?
Yes.
Yeah.
Yes.
One divided by 2.
MR of nitrogen is 14, so times 2.
Yes, I know, but that's 2 nitrogen molecules, not 1.
Yeah, so it's 28.
Hang on.
Nitrogen.
Hang on.
2 not 1.
Hang on. The molar mass of nitrogen is 28.
2 molecules of nitrogen.
One molecule.
One molecule of nitrogen, 2 atoms.
That's what's present.
Yeah, but that's not what we do in chemistry.
Yes, that's okay.
But no, I know, but we're not doing the exact same thing as in chemistry. We're just using the same formula of a weighted average. That's the concept. So the concept here is when you're mixing 2 things together and you want to average them, you need to use a weighted average. So if I want the average molar mass, I have to use the weighted average molar mass, because the alternative of adding them and dividing by 2 is not appropriate here. So, that's okay, yes? And then divide by 100. Yeah, so what answer did you get? 29.2. Yeah. Next one. Argon is at a pressure of 1.5 atmospheres and its volume is 50 litres. What will its pressure be if the volume is reduced to 40 litres? 1.5? No.
Increase.
It will increase.
1.
Because of Boyle's law.
1.6 something.
Yeah. But calculate exactly, please. Just do it!
Calculator on my phone. I want the answer on the calculator, so this was the 5th one.
I gave it to you in litres.
What's that?
What?
CV and RT?
You could, but no. There's a nicer way to do it. That sounds about right. So if you look here, you start off with 50 litres and you decrease this to 40 litres, and you start off with 1.5 atmospheres, and that should increase or decrease because of Boyle's law. 50 to 40 means you are reducing by 0.8. You're multiplying by 0.8. If you didn't know that, you can just do 40 over 50, that's 0.8. So then the pressure will increase by that amount, or in other words, you divide it by 0.8 because of the inverse relationship. So 1.5 divided by 0.8, what did you get, Yusuf? Correct. Atmospheres. 4 is going to be, I think, something similar. Oxygen is at 3 atmospheres at 20, and then and the volume is 100 litres. No, it's a different one. How many atoms of oxygen are in the tank? So first you could get the moles and then multiply by Avogadro. Got it?
Yeah.
Great. Right, let's see. So, what information do we want here? We want the N, so what's the form for N? PV over RT. Now, do we know the P? What is it?
3 atmospheres.
3 atmospheres. So that's 3 times 101.3, 5? 2.5?
Yeah.
325.
Huh?
Yes. Your PowerPoint says 3.5, but it's supposed to be 3.25.
Outrageous, outrageous. Times 10 to the 3. The volume is 100 litres, but we need to convert litres into meters cubed. No, not 100 meters cubed.
0.1.
0.1, very good. And what's the temperature? 293. And then we multiply the answer by Avogadro. And do we need to multiply by 2? Does oxygen occur in pairs?
Yeah.
And I asked for atoms?
Molecules.
Did I ask for molecules or did I ask for atoms? Atoms. So multiply this answer by Avogadro, then multiply it by 2. What number? Oh, you're typing that in, yeah?
I got
3 times 101.325 times 10 to the power of 3 times 0.1 over 8.31 times 293. This is how many moles I have. Multiplied by Avogadro, this is how many molecules I have. Multiplied by 2, this is how many atoms I have. 1.5 times 10 to the 25.
Why is the pressure 325, not 350?
The number, chemistry, we took, it was 101.325, not 101.35.
But the one we took in.
No, I typed it in wrong in the PowerPoint. That's what we said. Anyways. Okay. Delete question number 6 and number 5. I want to leave you something to do by yourself, so I can do number 5 at the start of the next class. Number 5 was a section A exam question. So if you want to know what they look like in the exam, it could look like something like number 5.
What's wrong with 6?
I think I screwed up the numbers in it, so it's easier for me just to delete it and retype it for next year. Yeah. Okay. Okay. I need to finish a little bit earlier because I have 80 kilometers of driving to do. So